Assalamu alaikum warahmatullahi wabarakatuh. Hii ni integration. We have a question there. Evaluate the integral from 0 to pi over 2 sin 2x all over 1 plus cos 2x dx. So kitu ya kwanza ukipewa swali kama hiyo ni kujua kwanza ni technique gani bora zaidi ya kutumia kufanyia swali kama hiyo. So tukiangalia swali letu, technique nzuri yenye tunaweza fanya hiyo swali ni u-substitution. So tutatumia u-substitution kwa kuwa tukiangalia the derivative of cos 2x ni 2 is minus 2 sin x cos x, ndio. But ukiangalia pia sin 2x hii iko under double angle. Ukichunguza sin 2x is the same as sin sin 2 sin x cos x. Ukienda kwa double angles unapata sin 2x ukifungua inakupea sin 2 sin of x cos of x. So hebu tuone then change plus substitute. For example, let's substitute u equals to 1 plus cos 2x. Therefore, kama u yetu ni 1 plus cos 2x, therefore du dx itakuwa ni, so the derivative of 1 is 0 because it's a constant, and the derivative of cos 2x, it will be first the derivative of the whole function, which is 2 cos x multiplied by the derivative of x squared of cos x, which is sin of x. Cos x can be written as cos of x squared. Therefore, the derivative of the outer function, it will be 2, we multiply by 1. The coefficient of the whole function is 1. Kisha, baada ya hapo, una multiply hii function yote na 2, kisha 2 tuna minus the power, tuna minus 1 inabakia power 1 multiply by the derivative of the inner function. The inner function, we know that the derivative of cos x is sin x. So that's what I've done here. So after that we have the u dx, but our new function now, it can be written as, but we can see here there's dx, so we can make dx as our subject. So therefore, dx, it will be du all over 2 cos x sin x. Since now we have said that this is u, we have substituted 1 plus cos squared of x with u. We can come and substitute now to our function. So we have to integrate from 0 to pi over 2. So sin 2x all over u, then we multiply this by du all over 2 cos x sin x. So kitu cha kuelewa hapa ni kwamba tulitumia u substitution kwa kuwa tuliona tukidifferentiate hii equation hapa chini, tumesubstitute ili tukidifferentiate tunaona tunapata 2 cos x sin x. Ndio tukiona hii sign, unaona hii sign ni kwamba ina cancel na, so kwa kuwa hizi mbili ukidifferentiate una substitute ili ujue kwamba kuna vitu zinaweza cancel. So unaona tukitumia u substitution hii hapa ita cancel na hii hapa juu automatically. So u substitution sometimes unaangalia una substitute kitu ambayo ita simplify your function. Tunaona tulivyo substitute na hii tukidifferentiate inakuja automatically ina simplify my function. So as hii ni kama tu matayarisho ili tukuje tufanyeje, tu integrate rahisi. Ikiwa vile ni ngumu integrate, lakini ukirahisisha una simplify inakuwa rahisi wewe kufanya nini, integrate. So ikifikia hapa sasa tunaona in trigonometric sin 2x it was sin of x plus x. Ukiapply double angle sin of 2x, it will be what? we say is the same as 2 cos x sine of x. Therefore, tunaona hii sine of 2x is the same as, so we can replace it there. So it will be the integral of 0 to pi over 2 of what? 2 cos x sine of x all over what? All over. By the way, this one has to be negative. It is negative because the derivative of cos x now, the inner function has to be minus sine x. So this has to be negative. So it will be u of minus 2 cos x sine x. So this function, now we have written sine of x is the same as this one. Therefore, we can write this function as 2 cos x and x all over minus u2 cos of x sine of x du. Therefore, 2 cos of x sine of x, they cancel out. We remain with 1 over u. But we know that the derivative of natural log of x is 1 over x. Therefore, 1 over x is the same as the natural log, the derivative. Now, when we integrate, this has to come back to natural log of x. So it will be natural log of what? Of u. Then plus constant c. But our u, we substituted our u with what? Remember, we substituted our u with 1 plus cos squared of x. So our u will be 1 plus cos squared of x. Therefore, the integral, so from 0 to pi over 2, the integral of that will be a natural log of 1 plus cos squared of x. Then plus, so since we have to subtract again, we take the upper limit minus lower limit. There's no need to add the constants since they'll minus each other. So we have to just take the limits from 0 to pi over 2 of this function. So we substitute with here with pi, with cos here with pi over 2. Then we further substitute with 0. Therefore, the natural log of 1 plus cos squared of pi over 2. Then we minus by the natural log of, so negative natural log of what? 1 plus cos squared 0. So we were here. The natural log of 1 plus cos squared of x from 0 to pi over 2. So we had to substitute where we have x with pi over 2, and we minus when we substitute where we have x with 0, the lower limit. Now, after substituting, we end up with the cos of pi over 2 is 0. When we square it, 0 squared is 0. So 1 plus 0 will remain with 1, and cos of 0 is 1. 1 squared is 1. 1 plus 1 is 2. The natural log of 2 is 0.6932. So but the natural log of 1 is 0. So the positive sign comes from minus this function. Therefore, it will become positive 0.6932, and that is our final answer.